Tēnā koutou katoa. Thanks for being here. This is a talk about AI and combining generative AI and more general AI, symbolic AI, to see if we can make tools that can help us see the truth in scientific claims. Someone makes a claim or a statement and you would like to fact check them in real time. Parents, grandparents, strange uncles. This is a talk that maybe shows you how you could do that. I want to acknowledge that the person who deserves the most credit for this work is Neshet Tan, who's my postdoc. And also want to shout out the Allen AI Institute, who we partner with quite closely on this work. They support us by giving us access to their API keys, which means we get to use large language models, commercial grade ones, for free, which is great. And they also put some people into this project too. So let's start. When computers first emerged in research in the 1950s and the 60s and the 70s, they were used to scale up analysis and modeling activities. And so they impacted some fields like computational chemistry, or created some fields like computational chemistry. And other fields were not touched by this new development. But this time it's different. As we grasp what generative AI can do, or will do soon, it's clear that the impact on research will be massive. It won't just be that we build high-performance computing models and simulate things more. Many other activities in the research life cycle will be augmented by AI, like how do I understand the research literature? How do I write a summary of all that's happened so far? How do I figure out if the claim someone has made in a paper is actually supported by the literature, or is it refuted by most literature? This is where we're kind of trying to position these tools. The amazing emergent behavior we see in Gen AI is a result of what Peter Norvig calls the unreasonable effectiveness of data. The remarkable ability of large data sets to produce accurate models, even when the algorithms used to analyze them are really quite simple. Shockingly so. So I thought I'd start with just introducing 3 anonymous science claims that I found in the media, news media. Just picked them up by accident. There's no connection at all between them, honest. I'll leave you to think about that. People say some dumb stuff, and sometimes it would be nice to say, hang on, I'm sure there's something written about that that we could maybe explore. Learning to separate verified scientific facts from speculation or falsehoods has, or at least it had, important consequences. I'm not sure that it does anymore, but I'd like to think so. But science and scientists are part of this problem too. We make claims that are not supported by our own research. And often press releases contain exaggerated advice, particularly in the drug industry, and many papers contain exaggerated claims or unqualified claims. So we need to also turn this kind of tool on ourselves as a community and say, how could we do better at not exaggerating or widening the claims that we make? Can we strengthen public confidence in science or in research by providing tools to evaluate claims that it makes? Make it a little bit more transparent, and at the same time provide the evidence that links the claim back to the research so that someone can read it for themselves. There is a paper called "Everything We Eat Both Causes and Prevents Cancer," just to make the point. And every dot on that graph is a paper that supports or refutes the idea that some particular food supports better health or is likely to give you cancer. The point is that even the academic literature is not clear on what is true. But better ideas do rise to the top over time, while more unreliable or unrepeatable claims tend not to be cited. So in the system we're building, we use this idea of trying to find not just science to support a claim, but the best science to support a claim. Let's also have a look, before we just get into the system that we built, to look at what Gen AI cannot currently do. It can't make sense of your questions or its answers. It can't distinguish reliable from unreliable sources. It's trained on a general crawl of the internet, plus a lot of other things now, not reliable sources. It can't learn from few or no examples. It can't translate languages without examples. It can't let you know when its answers are likely to be unreliable. Actually, that's not true. It can now. Usually it doesn't, but it can be done. It doesn't deal well with very long contexts. By that, I mean a document where an idea might appear at the beginning of the document that's then linked to an idea at the end of the document. There's a distinct range limit on current large language models, and they don't suit research. Our conversations are long and ongoing. We pick up ideas not just in the paper we're writing, but in other papers over the last 50 years, sometimes longer in some fields. That context is massive and hugely challenging for large language models as they exist now. They can't reason effectively over such large contexts. It requires too much memory, too many parameters. Also, tools that assess the truthfulness of claims in research documents are almost always very domain-specific. They're trained on a particular corpus of facts and can only work in that very limited, narrow scope. There are some data sets that have been created that contain facts like climate fever and COVID facts that you can train models on so they can hunt out where facts are abused or misquoted. Making these data sets for training is really complex. You have to scrape the internet to find domain ontologies, online examinations with marking guides, any other sources of what you might regard as true or reliable. It's painful, and these training sets need constant maintenance. So what we wanted was a general solution that needs no training, that will work on any research question sight unseen. So the system presents a prompt, you type in a claim. The incident rate of cervical cancer has increased over time. The system searches the literature, brings back relevant documents, reworks those documents according to your claim, marshals the evidence, presents it back to you with some reliability estimate. Let's talk through how it might do that. In fact, for most claims that we might make against the science literature has very qualified responses. This situation is true in Ethiopia. It is not true in most of Western Europe. Why is it not true? And how do you help a large language model reason over topics like places where it has no concept of Ethiopia or Wales or Europe? It doesn't understand any of that text, but bringing back a nuanced understanding from that text is really important. And this is the answer at the bottom. You can see that the response from the system is very qualified. It deals with the geography and the differences between developing countries and developed countries in the answer it gives back. That answer required no training and simply works. You can pick up any example you like. I'll give you a few more examples before I finish, but I want to delve in a little bit to how it works. So apologies for the smallness of the font. I wanted to try and get the whole of the system on a slide for you. Don't worry if you can't read the details. Look on the left-hand side. First of all, you put in a claim. We also create the converse of that claim, and we set off two queries, one with your claim and one with the converse of it. The second step is to retrieve documents, scientific documents, that might support or refute that particular claim. In other words, they align with it in some way. Then we figure out what the takeaway message from those documents might be if they had been written to only support your question. So we rewrite the document so that it addresses just the question. We then figure out whether the question is supported or refuted in those answers, in those takeaway messages, and to what extent it might be supported or refuted. We then score the documents themselves in terms of their reliability. I'll come to that more in a moment. And then we create a global explanation, and then we produce an attribution for all of that so that you can drill down into the details. Where did this idea come from? Show me the actual literature. Let me read it for myself. Just to go into a little bit more detail, the documents themselves come from having access to the APIs for Semantic Scholar, Google Scholar, PubMed, things like that. When we find journal articles that support or refute a particular query, we rank them according to the journal ranking itself, the number of citations of the paper, and the number of citations of the author. So we've got 3 different measures of standing, which we combine to give a kind of trust score for a paper. It's not perfect, but it helps us weed out stuff that hasn't been referenced or that comes from really dodgy industry-supported journals with ulterior motives. There's a little bit of that. We use computational linguistics, particularly I think called textual entailment, to figure out what part of a document might support or refute a particular query that we might make. So that's old school computational linguistics, natural language processing. Then we combine those sources, that's from one source. We combine those sources across multiple documents to try and get at what the truth is of that particular claim. We combine the evidence. So there's the supporting and the refuting query. Here's the evidence that supports them. Here is that evidence marshaled and created, formed into an explanation at the bottom. Without any retraining, we can ask, what about CO2 in the atmosphere? Is that due to humans? Well, yeah it is. if there was any doubt, there's the answer. Digging into the supporting evidence on this example, here's the abstract takeaway messages, here's the takeaway as bullets, here's the local explanation, here's a verdict. All of this was done with large language models, rewriting documents and focusing them on a particular topic. Here's another one. Gender-affirming treatments can reduce the risk of suicide in adolescents. The answer is yeah, mostly. And here's more of the evidence that comes out of the system that you can drill down at. You can look at how many documents were retrieved, which ones supported or refuted that particular claim. You can go and read them if you want to. You can dig down into a particular paper. There's its abstract. There's its takeaway message. There's a local explanation rewritten to support this particular hypothesis or query. And there's the reputation score, in case you were wondering just how reliable this particular source is. And again, eating spicy foods causes stomach ulcers. Does it? Does it not? When in fact, this is proved to be not true. It's down to a Helicobacter pylori, which is the primary cause of peptic ulcers. So it's the kind of system that you can use to ask really targeted questions as an expert, but you can also use it to ask really quite general questions as someone who consumes a lot of Indian food and is perhaps concerned about the welfare of their stomach lining. We evaluated the system against human expert responses, and it works really well. So, outcomes. It's possible with 80% confidence or better to evaluate the truth of claims made against the research literature without any training, without any pause. The results will get better as LLMs get better. For example, when we can access a whole paper, most papers are behind paywalls. Most publishers don't want you going behind their paywall with your large language model. But that will change, I think. Answers are not yet instantaneous because large language models aren't instantaneous, as you know if you use them. Think about how long it takes to create an image. And the elapsed time is 1 to 10 minutes per query if you run it in a serial way. Nor are they cheap because it costs about $1 to $5 USD per query, and we need 100 to 1,000 every time we run one of these tasks. That's why it's really helpful for us that we partner with Alan AI, because essentially they pick up the bill for that. So thanks, Paul Allen. Summary. We built a tool that's supervision-free. It's open domain. Any topic can be explored. It aggregates and reasons over multiple evidence sources. It presents argument and counter-argument. It considers reputation for each source. It shows its reasoning back to source documents. It is useful. It evaluates any science or research claim against the existing literature, provides a summary, uses reputation metrics, provides full evidence of its working. Here's where it gets interesting. You can also use this to validate claims that authors make when you're reviewing papers. You can say, well, where does this idea come from? And is it really supported in the way this author is claiming it is? Or if you are writing a paper and you want to make a claim, this is a way that will find you not only the supporting literature, but write you the supporting evidence, the paragraph that explains how the supporting literature supports the claim you want to make. So I think this will be used by researchers when they're writing, as well as by people when they're trying to understand science better or to query and question it. If you want to find out more, there's a paper you can read. It was published last year in a fairly prestigious AAAI conference. And we'd love to chat more. If you have any questions, got 2 minutes left, happy to take them. Thank you very much. Please feel free.
Okay. I'm just curious. So we're talking about modifying LLMs to make them more accurate. And I'm just thinking, up to this point in history, we've written research and papers and books and publications for ourselves. And if AI is going to be so fundamental in the future, the suggestion this morning in the keynote where, what if we just delete the internet?
Yeah, right.
We're not going to be interacting with
an
HTML page.
Yeah.
Maybe not, but is research going to change? Is the methods and the way that we publish, is that going to change to fit the AI at some point instead of the other way around?
Yeah, look, I hope the way we publish is going to change. It's so broken. We pay publishers to put papers behind paywalls, and then we pay them again to put research in front of paywalls. We're crazy. And it's not an efficient way of consuming ideas. And I think the idea about deleting the internet, although it's perhaps a little extreme because that's what we train from, the tools that we have now essentially allow all of us to consume all the content that we've put on the internet in a way that actually makes sense to us. We don't need to know where to look anymore. That is a huge advantage. But yeah, I think AI will challenge many research norms, the way we do things, the way we report things, the way we validate things. That will change, yeah. There's one more question if I have time.
Yeah, Mark, I think we may have spoken about this at the conference last year, but the idea that what you described, bearing in mind this is relatively new work, evaluates truth and consensus. Those two words sit very difficultly.
Yeah. Yeah.
And I think a great example would be one you provided, Peter Leffler.
Mm-hmm.
Right. Okay. Up until the point that that claim was made, it was widely refuted.
Yes.
That it caused
yes.
ulcers.
Yeah.
And the idea that a consensus can change is a difficult thing for an LLM to take into account. Would you agree or
No, I do. And I think the more successful systems in the end are going to need to be constrained by domain ontology, semantics, that is well maintained. And I think our role as academics might change so that we are focused on maintaining truthful or at least reliable current data sets from which conclusions like this can be drawn. So that when the general internet is searched for advice on what to do if your stomach hurts, you can at least find a source which has more trusted, constrained answers to come back to you. Yeah. Does that help?
Yeah.
Yeah. Thank you.
Mark?